Hello everyone, and welcome to the very first lecture for Intro to Geographic Information Systems and Geographic Science and Information Science and Technology, or GIST. I'm doing this lecture together because, as one might suspect, the first chapter and the first things I want you guys to know apply for both classes. From this point on, it will get different for each one, but from here we can kind of lay the foundation for the subject matter here. Those are, and just so you know, Geography 1100 and Geography 2150 respectively. If you don't already know me, my name is Sarah Pellegrin, and you should have hopefully watched my welcome video I did send out a couple weeks ago. This class runs from September 21st/23rd, depending on the class, through December 11th, with labs on Mondays and Wednesdays, again, depending on the class. Okay, let's go ahead and move on. All right, so let's start part one and let's talk about GIS. So what is GIS? Hopefully you have some idea. It stands for Geographic Information Systems. What does that mean exactly? We're going to spend the next few slides sort of picking that apart and getting a sense for what is involved in saying something is a GIS. The quote I have here says that it is a system designed to capture, store, manipulate, analyze, manage, and present all types of geographical data. The key word to this technology is geography. This means that some portion of the data is spatial. In other words, data that is in some way referenced to locations on Earth. So ultimately, it's about geography. Get my laser pointer up there. Okay, but what is geography? You know, you say that to people and they go like, well, it's the capital of Florida. It's the name of this river. It's the name of this mountain range. And yes, those are all aspects of geography. But really, the essence of geography is understanding why things are where they are. It's about looking at locational relationships between things and locations. So what I have broken down under here are these points of people, places, and phenomenon. So these are the things up here. These are the things we're talking about. The things can be people, individuals, or groups. They can be places. They can be mountain ranges, like I said. They can be cities. Or phenomenon, things that happen to these people and places. Weather patterns, diseases, flooding, crime, etc. All of these things can be tied to a location and be related to one another. And that is sort of the essence of geography. And just as a side note down here at the bottom, I highlight that GIST is the use of technology to actually gather data, gather the why and the where about these things. And we'll go into that a little more detail later on. So thus, it's all about location. Location is the primary mover in this understanding of what goes into a GIS. And this is at the core of a geographic information system. Now, this is a term you're going to see a lot. It's called geospatial data. And this is data that it does have a shape of some kind. It can be a single point, it can have boundaries or be a line, or it can be like a pixel of a photograph. And all of these kinds of geospatial data will have information attached to them. If we move over to the right of the globe, this data is made more meaty, interesting, and analyzable by the associated non-geospatial data, which is also called attribute data. And it's the why behind the where of the definition in geography. Now what this is and you'll understand this as we sort of continue through this discussion, but non-geospatial data is all this sort of information we can attach to the geospatial data. And the geospatial data is primarily let's say the coordinates that are attached to a thing. And the non-geospatial data is the stuff that tells us about what's at that point. Okay, so moving forward. So let's rewind a little bit and think about where GIS comes from. I mean, you think GIS and you think it's a 21st century or 20th century development. And to a large extent it is, because the technology we have is clearly based on powerful computing systems. But in reality, a geographic information system is any system for helping us organize information about a place in a visual format. So we look at maps, like we can look at these examples of maps that are over 1,000 years old and well over 1,000 years old here in this example. And these can be called GISs because they have information represented as shapes on a map that hold data. Now, when I talk about holding data, the data is held in the mind of the reader, or it could be on the map in the form of a legend or some kind of explanation. But in general, it is a system for organizing information about geography. Over time, in the last 600, 800 years, people started to measure the Earth with a little more accuracy and to think more critically about the shape of our physical geography. And we came up with things called datums, geographic coordinate systems, and projected coordinate systems, things we will again discuss later on in this lecture. But these two became more refined versions of geographic information systems. So again, a system for organizing information about a place. So as we progressed and we thought more critically again about what goes into this map, the system, there was this understanding that what goes into a map can be represented in different ways. So we can have the points of a city, or we can have the boundaries of a county, or we can have the topography of a mountain range. And when we talk about building a GIS, we talk about building it in layers, and these are kinds of information that represent different layers. And it was this sort of layering idea that became instrumental in being fed into a computer system. So this is all a very truncated, over-generalized version of how this all developed, but generally speaking, once we thought of things happening in layers, and we realized we could use computers to sort of calculate how things came together and meshed together, it helped create what we now know as a GIS. And this is just to highlight some of the factual development behind GIS. It actually has a sort of a history that reaches back into the 1960s from this guy here, Dr. Roger Tomlinson, who came up with a brilliant idea, flying an airplane over Canada, so the story goes, that we could combine emerging computer systems with all of this geographic data that was starting to become more and more prevalent. So he came up with the Canadian Geographic Information System, and that's where it started. All of that filtered down, made its way to Harvard in the 1960s, and a young man by the name of Jack Dangermond was a student at the, I think, Landscape Architecture School. And he sort of came up with the idea of, he further refined this idea that Tomlinson came up with. And he was instrumental in really marketing it and using it. And he and ESRI, which stands for Environmental Sciences Research Institute, have been instrumental in pushing forward the technology over the last over 50 years now. There are other groups that create their own GISs, but ESRI is by far the heavy hitter in the industry, and it's who we use for our own software systems. So what goes into a GIS? We have to have a powerful computer. We have so much data we're working with, so we need really powerful computers, and they're computers that are systems that are increasingly cloud-based. So we're not working as much anymore from our own processors on our laptops, but we're using the processing power of remote servers. Ever advancing software. We have, as I've stated about the textbooks, we have brand new textbooks this semester because the software has changed so much that we just had to actually change the book altogether. And everybody who's using ArcPro right now is still relatively new at it. And as I mentioned before, massive amounts of geospatial data. In GIST, we will go into a little bit more about what that means exactly. I like to call it big geospatial data. But there's a lot of it out there, and we can set up algorithms and AI to process all of that. Or we can just use it on our own and try and mine it ourselves. And at the back of all of this, of course, we can't forget about the human component, because we're the ones who create the problems. We're also the ones who try to solve them. So we can try and identify new ways of thinking about things and creating linking relationships and spatial patterns, and helping to kind of create solutions to the issues we see in the world today. And that can be anything from involving physical geography to social geography to human geography. So it can go across the board. So getting all of this amazing geospatial data and attribute data This is all done through our technology, and this is going to be the at the heart of what we go into in GIST. But you can see here, some of these are kind of old tech representations, but this right here is a handheld data collection device for collecting field data. And these two devices here are used by surveyors because surveyors use GPS, this little GPS antenna. So everything they do is sort of linked automatically to a very precise location. Drones collect a lot of geospatial data nowadays. Not to be outdone, of course, by satellites, which is a very exciting and technology that is on the cusp of everything we're doing now. But this perhaps is the most important. It's our cell phones and our personal computers. Cell phones probably most important because I think so much of what's pertinent today with all the big geospatial data collection that's happening is it's all happening through our mobile devices, and we can collect so much information about anything, and we can tie it to where you were at the time because of our phones and also because of our computers. Our computers have IP addresses that tell us exactly where we're located when we're using things. So lots of words on the slide. This is all just to say that who uses GIS? Everybody uses GIS. Everybody can use GIS. Some rely on it in more obvious ways than others. But honestly, you give me a subject, give me something that even seems not even somewhat related to geography, and I can come up with a way that we can find information and map it using a GIS. But it's just to say that this is integral to so many things that are out there, and if you have GIS skills to bring to the table, it'll serve you well in a lot of industries. So this is just a brief overview of some of the cool things we can do in a GIS. So when you think GIS and geography, you probably think of producing a map, and that is completely true. We do make maps, static maps, but we also make maps that are active, that we use to actively do analysis and put in different numbers and rework what we're looking at. And so this is an example of some of the fun things we do. Right here on the left, this is called a viewshed analysis. This is produced by having an observer stand at a certain point where we know the location and the elevation, and it shows us exactly what they can see. So that red is what they can't see, and the kind of the green map part is what they can see. This is a LiDAR point cloud showing the shape of what it looked at. This is a drive time analysis looking at how far you can get from a given place in a certain amount of time. This is just showing terrain and ideal path. This is watershed analysis. And this is just some simple geospatial analysis or spatial analysis doing buffers, which is really fun. Okay. Big data, the internet, and the future of GIS. I kind of have already mentioned this, but just to sort of reiterate the point that more and more we are getting all of our data from this ever-evolving platform of big data that's coming from all of the users out there in the world who are voluntarily or involuntarily creating more and more data with their mobile devices. But on the other side of that is the fact that GIS is now becoming a lot more cloud-based. This is becoming, so the thing with Esri and GIS that we do is it has been in the cloud and it has been accessible over the internet for many years now. But it's even more important that we do this now in this sort of new pandemic era where everybody is working from home, and this is an acceptable thing to do because it's proof that this is a sustainable way of working and doing analysis. And Esri is already set up with some really great cloud GIS options. So let's see, one last thing. So I had mentioned that I mentioned that we use Esri, and I did say that there are others. There's one called GRASS, QGIS, and even within Google Earth, there's a lot of analytical capabilities, which is to say that there are other options out there for conducting geospatial analysis, but we use Esri just because, again, they're the gold standard, and they have really great access for students and for learning and for educational institutions. And there's a lot of products within the Esri family that can be used depending on what you want to do and achieve. Okay, so this is part 2. So this is just some essential things to know before getting started. So basic components of doing GIS. These are the 3 things I have decided are most important. Coordinate systems, which we would want to know. Everything has to have a coordinate system. If it doesn't have a coordinate system, it simply can't exist because the coordinate system tells us where something is on the Earth depending on the kind of measurements you're using. It has to be composed of geospatial data, which we already went through, and it doesn't have to, but it often has some kind of non-geospatial data. So let's dive in a little bit more into what each of these is. So coordinate systems, this is actually a big topic that we cover in GIST, but just to give you a brief intro into what it is, it's divided into two different kinds, which is geographic coordinate system and projected coordinate system. Otherwise known as the GCS and the PCS. So GCS is sort of where we start from, and it tells us where something is located on a sphere. So when we think of a sphere, of course, we think of planet Earth, and people have spent a lot of time measuring what the Earth actually, how big it literally is. And when we talk about a location on a geographic coordinate system, it looks like this, something we're familiar with seeing, the degrees and the cardinal direction. Now, the projected coordinate system is built upon the geographic coordinate system, and it tells us where something is on a flat map. So if you think about taking a sphere to a flat map, and there are a lot of different things that happen, and we'll go into that later in another lecture, but the measurement of the coordinates that emerge from something like that looks like this. It's a giant number next to a giant number. It can either be meters or feet. So in essence, a GCS defines where the data is located physically on the Earth's surface. Well, a PCS tells us how to draw on a flat surface like a paper map or computer screen. And just one caveat, knowing a coordinate system is completely essential to producing accurate maps, as we'll find out. But to be honest, the software does a lot of the heavy lifting for you. It'll transform things if they're not in the same coordinate system, and it'll do all the math for you, but you still need to know. Okay, geospatial data. I covered this already in verbally before, but just to show you a little bit more about how geospatial data looks and the forms it comes in. So there are two kinds. There's vector data and raster data. Vector data are points, lines, and polygons, and you'll hear those mentioned often throughout these classes. Points, lines, and polygons, vector data. This vector data can be drawn in kind of a two-dimensional format. The vector data can have text, nominal, ordinal, interval, and ratio data that is visible on an attribute table. So if I were to double click on a point, like that one right there, then I would have this kind of Excel spreadsheet looking thing pop up in another window, and it would tell me all about that point, what's at that point. Same thing with the line and same thing with the polygon. So each of those elements of those shapes has data within it. So over here at raster data is another way of saying imagery, satellite imagery, among other things. But we're all kind of familiar with this idea that things come in pixels. Photographs are composed of little tiny squares, and that's essentially a raster. Those little tiny squares, those most basic building blocks of an image, also have geographic data, attribute data attached to them. So you can hold a lot of information about something within each of these rasters and in the photo itself. So non-geospatial data, as I talked about before, is that kind of descriptive data about a piece of geometry, as they call it as well. So if we look over here, I tried to pull up an example from our census data. Census data is a very great place to go when looking for data that's very well organized by shape, because they do something called census block groups. So you can see on this map, there's all these different rectangles that have different colors. The rectangles are actually census block groups, and that's called a polygon. So if you were to click on one of those polygons, it would open up this, like I said, an Excel-looking spreadsheet, and it'll have all the demographic data for every person who lives within that block group. We'll get a chance to go look at some census data in more detail in other lessons, in both classes. It's really quite interesting what you can do with it, and relevant since we're doing a census this year. I spoke about layers again as well. These layers, like I said, you can put many layers into a map, and relate the layers to each other using geospatial analysis tools. So we have our vector data and we have our raster data. And yes, you can build those together. You can build these layers here. But this slide is to just show you that all of this information lives in something called a geodatabase. And the geodatabase is how we sort of organize and keep our data from flying all over the place. And just one last thing to note, if you were to open the data for your labs in a non-GIS software system, it would look like this, and it would be complete gobbledygook. Don't mess with those files. If you ever do that, you go, oh, what is all this stuff? I don't need it. No, just don't touch it, because it'll ruin all the files that when you do open it up inside your GIS will look like this. It'll be nice and tidy, and it'll be the different layers and the different polygons and the different maybe raster files that are there as well. So this, which there are 66 items here, represents these 5 little files here. So I'm not quite sure why it does that. That's beyond my remit, but it's just to say that don't mess with it. Just leave that stuff alone. This is what it turns into when you look at it within your GIS file organizer. And one last thing before we close, we'll try and kind of keep up these helpful little practical hints. When we're working in ArcPro, the right click is king. I feel like there's always like when you're working in Microsoft Office, which is ArcPro is set up a lot like that now. Right clicking on something can get you a lot of places, can solve you a lot of problems. So don't forget to right click if you're ever lost. Okay, so that's the end of that one. I hope that was interesting and gives you enough information to get started and not feel completely lost. I look forward to working on the next lecture for you guys. Thanks very much.